morning all of you, and here is a beautiful JEE advanced question to compare these two integral. Before we start, let's see how the integral look like geometrically. So e to the power x square will roughly be like this, and e to the power minus x square, as you can see, as it will also be an even function. So it will be roughly bell-shaped graph. Since it's differentiable at x equal to 0 and the slope is 0, hence it will be smooth. Now the question is 0 to 1 e to the power minus x square dx is the upper limit of integration. So if we'll see 0 to 1, we'll get this area. And then we have to integrate 0 to this value e to the power x square. Okay, so as you can see on the head we have comparatively lesser value, but the integrand is larger value. Versus e to the power minus x square dx and 0 to 0 to 1. So 0 to 1 e to the power x square dx will be comparatively greater value, but the base e to the power minus x square is small. So it's clearly a tug of war between these two integrals, and let's see how we can evaluate this. Now before we go further, it's better to define a new function f of t, which is 0 to 0 to t e to the power minus x square dx. So fundamentally we want just the value at f of 1, right? In expression I can clearly see f of 1 and g of 1 I need to compare. Now as you can see, f of 0 is 0 and so is g of 0. Since if I'll put 0, this upper head integral will be 0 to 0 something, which is 0, and same is g of 0. So now what we can do is we can differentiate f. So let's differentiate using Leibniz rule. So f dash t is differentiation of our limit of integration, which is e to the power minus x square, and into, we'll put the upper in the expression. So we'll have e to the power 0 to t e to the power minus x square dt whole square. This we are doing nothing but simply Leibniz rule into picture. And similarly g dash t gives us e to the power x square into e to the power minus of 0 to t x square dx whole square. Right? And now from these two expressions, as you can surprisingly see, f dash by g dash, f dash t by g dash t is gonna give me e to the power 0 to t e to the power minus x square dx whole square, because when we'll divide, plus 0 to t e to the power x square dx whole square, and we are left with minus 2t square. And that's an interesting news, because now we are getting a feeling of something a square plus b square, and that motivates us to bring AMGM. So let's say 0 to t e to the power minus x square dx whole square plus 0 to t e to the power x square dx whole square. Anyway, this both quantity is always positive, right? At t equal to 0, it will give 0. So if I apply AMGM, this will be greater than equal to root over 2 times of this into this. So root will get dispelled off, and we'll get simply 2 times of. So using AMGM inequality, now a square plus b square will get an equal to 2ab. So it's 2 times of 0 to t e to the power minus x square dx times 0 to t e to the power x square dx. Now here we can little bit manipulate this expression using something called Cauchy-Schwarz inequality. Now that is an interesting thing, because this quantity can be written as, so let me just tell you what is Cauchy-Schwarz inequality for integral. If I see x times f of t plus g of t whole square, so this will always be greater than equal to 0 for any x belonging to real number, right? So let's say if I defined, which means x square times, if I give integral a to b, so anyway, if I integrate from a to b xf plus g whole square. So it will also be greater than equal to a to b 0 dx, which is just 0, which amounts to x square times, because it will be like a constant, and ft square dt plus 2x times a to b ft gt dt, and we are left with a to b gt square dt. This is greater than equal to 0 for all x belonging to. तो यहाँ से if it is greater than equal to 0, x square is positive, so it must be upward parabola. So the only possibilities is d must be less than equal to 0, and that gives me a to b f into g whole square is less than equal to a to b f square dt, and into a to b g square dt. Into a to b g square dt. And that is essentially Cauchy-Schwarz inequality for integrals. In the similar fashion, you have done Cauchy-Schwarz inequality for algebraic expression where a dot b is less than equal to magnitude of a and magnitude 2b. Right, and this was amounting to, algebraically it was amounting to, let's say ax plus by for two variable is less than equals root over a square plus b square into x square plus y square. If we'll add one more expression, x plus by plus cz, it will be abc and xyz. Right, equality case will come, and vector a is linear combination of, so it's collinear with vector. It means the ratio of coefficients should be equal. A by b should be x by y. Okay, so having done this, now we are able to attack this problem from here. So I can know by from here now using Cauchy-Schwarz, this will be greater than this expression will be greater than equal to, as you can see, it's I can write this, it will be greater than equal to 0 to t, and I can multiply these two functions together. But remember, Cauchy-Schwarz whole square was there, so I have to take e to the power minus x square by t into e to the power x square by 2 dx. And that this is nothing but simply this is 2 times of t. So finally what we got is this entire expression f dash by gt, because this is 2t, right? This is always greater than equal to, now we have proved it's 2t. So f dash t by g dash t is e to the power 2t minus 2t square, so it will definitely be greater. So now f dash t by g dash t is greater than equal to e to the power 2t minus 2t square. And since we know t is belonging to 0 to 1, according to the problem statement, we want to integrate from 0 to 1. So in 0 to 1, clearly 2t will be more than 2t square, right? So hence I can tell 2t minus 2t square will be greater than 0. So hence this quantity will be greater than e to the power 0, which is greater than equal to 1. So it will be greater than 1 because equality will happen only at 0. So now from here we concluded f dash t is greater than g dash t for all t belonging to 0 to 1. It means function f is growing faster than function g, right? And both are increasing, and we stated the fact that f0 is 0, g0 is 0, and I know the slope of function f of t is always more than slope of g dash t. So if it is more slopey, so f of x will look like this. Similarly, g of x will look like this. So from here I can tell the value of the function at 1 will beat the value of another function g at 1. Like AMGM in basic integration can be asked. Okay, so I hope you must have understood this and it added to your conceptual understanding.